From Medford, Massachusetts comes Electrified Thermal Solutions. Presenting for Electrified Thermal Solutions is Donnie Smith and Daniel Stack. Give them a round of applause.
My name is Dan Stack, co-founder and CEO of Electrified Thermal Solutions. We're working every day to decarbonize the hottest industries with electrified heat.
Thank you. So we have a massive problem today. There is no affordable way to decarbonize our heavy industries. Talking cement, steel, glass, what makes the chairs you're sitting in, the walls of this building, it all requires a tremendous amount of energy. And that energy needs to be three things: cheap, reliable, and hot. Flame temperatures in many cases, as you see on the screen here. So our zero carbon energy sources are just one out of the three. They're cheap. And that's already remarkable, but that doesn't run a 24/7 cement plant or a steel plant. As soon as you try to make it into reliable heat, you lose the cheap part. Say if you want to make hydrogen with it, use 6x the cost, which won't work. So we need a new approach. And that is why we founded Electrified Thermal Solutions, and it is why we've been developing the Joule Hive thermal battery. With this system, we take in electricity from solar, wind, nuclear, or hydro. When it's cheap or abundant or available, we turn it into heat into our box, and we make hot gas with it that can run your furnace, your boiler, your kiln, even turn a turbine in place of where you normally burn fossil fuels. So with this one system, the Joule Hive can turn that intermittent zero carbon power into industrial reliable heat. When I say industrial heat, I mean 1800 Celsius, really hot. Hot enough to do any job we need, and just as good as hydrogen, but 3 times or more cost effective, so still affordable. And most importantly, we can retrofit existing systems. We plug into your furnace, your boiler, and so you don't have to radically redesign what you're doing to decarbonize what you're doing. And the Joule Hive is unmatched in what it can do because of a new patented technology that we've been working on, and that is the building block of industrial decarbonization, the electrically conductive fire brick, or e-brick if you like. With semiconductor doping, we've taken ordinary fire bricks that can withstand flame temperatures, and we made them into electrically conductive heating materials. This means we can go hotter and last longer than any electric heating material on the market today, and it means we can build with this building block to massive scales you see on the screen here. The green are the conductive bricks. When we stack them up, we can build systems that hold lots of heat for industry, and it operates as 3 things: a giant electric heater, a giant thermal store to hold it for later, and a giant heat exchanger. We flow gas straight through and make hot gas, which is what the world runs on. So this invention was roughly 10 years in the making, mostly during my time at MIT. You can see me very cheery here doing some lab work. It had humble beginnings in the wet chem lab, but ultimately I got to meet my co-founder, Dr. Joey Cable out of UC Berkeley, who can't be here today because he's expecting his first child soon. But we got to work at it building out ETS and working with mature materials from real fire brick companies. And so we'll go live now to the lab, go to demo at our lab at Medford, Massachusetts, and we can showcase our progress. So when we started with industrially mature powders, but then we moved to larger systems with full aggregates, full brick pressing capabilities, and then ultimately we scaled up 1000x in the last year or so to 1/2 a ton of bricks that are made of our conductive material. Our test rigs at the lab here are to test materials properties, but also to do active electric heating tests, like this one shown here, where we prove that our bricks can deliver the intensities, the temperatures, and the wattages that our industrial customers need to run their processes. This past summer, we commissioned our pilot scale facility, where we are stacking up full-size bricks, and we are electrically heating them to 1700 Celsius, and we are operating it in the conditions that industry will see in the Joule Hive thermal battery as we provide the heat that they normally get from fossil fuels. All right, thanks guys. We'll go back to presentation. So, and there's a shot of it here. I think maybe the camera froze, but this is what our demo looks like. An elevator-sized box where we stack the bricks up. We will be scaling that up to massive sizes. Shipping container sizes first, but ultimately to these tall towers where we can deliver hundreds of megawatts of heat to the biggest industrial customers, and that is what they need. And we know we can get there due to familiar industrial experiences already. So the first product, though, is about 5 megawatts in and out. We can put out up to 1800 Celsius, and anywhere in between, constant heat, constant flow to your industrial process. And that does the job of a lot of customers today. As far as where it can deploy, we can beat natural gas today in huge parts of the country. Where you see this purple plume that's formed in the last 5 years, that is renewable energy driving the price of electricity negative. I told you it was cheap, but it's actually, when you can grab it when it's in surplus, we can beat natural gas. For example, in the Midwest, we have roughly a 5-year payback where we can decarbonize 80% of your energy and save you money in the process. Even in areas where we have regulated utilities, where there's less incentives, you could still pay back with the Joule Hive compared to your next best option, say electric boilers. When people want to decarbonize, they want the cheapest way, we get a 3-year payback compared to those. And we have customers all across these different areas and across every industrial sector. Next slide. Where we're working them through our funnel, where they are working towards letters of intent and ultimately binding contracts, where we build our first system next year. We're going to have these on customer sites the year after that as we trigger these contracts. And that's in the steel, the cement, the glass, the adhesives industries, food and beverage, so a huge swath of folks. And they are also helping us apply to some really great government grants as well. So we plan to deploy aggressively 2 gigawatts and $500 million a year revenue by 2030. And the ultimate goal is industry electrified by 2045, a Joule Hive at every furnace, boiler, and kiln, roughly a $3 trillion market. We're looking for industrial partners to help us along the way. And of course, we'd love you to join our team, which is always growing. So please help us solve the toughest problems in the hottest space. Thanks a lot.
We didn't get to your question, Matthew, so let's start with you.
So when you're thinking of deploying these, who is your first, most juicy, wonderful, lovely customer? Who do you want to get to first, so that you can then prove out your ROI to the rest of the world?
Sure. So we have a bunch across different sectors. One of the best ones so far has been customers, usually big multinationals, especially chemicals, for example, that have mandates that are willing to, they need to get there, and they have relatively simple things to hook up into.
Regulatory mandates?
For example, in Europe, but they have international units. And so, for example, we've spoken to several of them who just say, we need the cheapest way to do this. And for example, they're in one of those regulated environments where the price, you can't just grab the wholesale negative stuff. You need to play by the rules of the utility. Even there, though, we are the cheapest option for them, and they're easy to plug into. They need about 900 Celsius, which is very comfortable for us. And there's a bunch of those like that are popping up.
How do you compare to propane, like on a per-cost basis?
Oh, much better than propane.
Okay.
But admittedly, what it really comes down to is the electricity price. So though the bricks, the box itself is very cheap. It adds very little to the cost of energy. The main driver is, can you get the cheap electricity? And as a storage asset, right, we can soak up the cheap stuff and give it to you 24/7. That's what allows us to compete. But propane is much easier to beat than natural gas.
You had Dana leaning in the whole time. She's excited. Let's go.
I mean, I am curious because I think you talk about it being able to retrofit and sort of being at price. Is it truly at price parity with existing solutions?
So it absolutely can be. And it again, really depends on where your electricity prices are. So there are certain areas it's not going to be at parity. But there's, that huge area of the map that we showed, Texas, the Midwest, where there's lots of wind energy, Wisconsin, Iowa, and you have drywall plants, adhesives plants, you have ethanol plants. That for them and for a growing amount of as that spreads out, and it does as we deploy more renewables, it's hitting cost parity, absolutely.
Because when I think about sort of how a business like yours, or anything that's sort of looking at sustainable alternatives, you really do need to be able to be at parity sort of everywhere. Because I think the regulatory enforcement is important, but commercial enterprises are going to adopt if it works for their business models.
People need the best price on
energy.
They
do need the best
That's
price on energy, and
so.
So it's really interesting. But you're saying you are dependent upon the price of electricity wherever you're operating.
That's right. The amazing news is that solar and wind have come down extraordinarily. Right? It's a remarkable thing that's happened. It makes this possible where now folks can look at this and say, I want that.
And do you distribute, like, are there traditional distributors that you already work with, or are you selling directly to these multinationals, or what's the?
Sure. So first off, on our system side, the bricks themselves we contract out. So we made a recipe that any brick manufacturer can make. So working very closely with manufacturers to scale this up rapidly. The rest of the system is kind of an integration process. Metal walls, refractory lined walls as well, and piping. And so you can work with a contractor to kind of deploy the box by the specs that we give. So big project developers can do the job, and we're talking with several of them.
Okay.
Rissa and then Charles.
I just had a couple of questions. One, so the material is just standard production fire bricks that you're storing the electricity in, is that right?
That's right, minus the secret sauce we have that makes them electrically conductive.
Okay.
It's a combination of those and regular bricks.
And it seems like a lot of times with energy and with heat, you lose a lot in the transfer. So it sounds like the plan is to basically build hives, if I understand it, that are co-located with the plants or the furnaces. Is that right?
That's right. We will co-locate them. You don't want to try and pipe really high temperature heat, many miles, say. Right. So the electricity comes in, and we store it there and deliver it, just through a pipe nearby.
And the bricks themselves aren't portable, or they are portable when they're electrified, or no?
The idea is
Can't
once
actually
they're
store
there,
it.
they're there.
Okay.
We're not going to drive hot bricks around the country.
And I was going to ask just about your go-to-market in terms of what size you're hoping to build for your first sort of flight of customers.
Absolutely. So that first unit, the shipping container size system, is a few megawatts, and that was based on customer feedback of what could do some of their easier jobs. There's a whole range of things, but so 5 megawatts, one or two of those boxes could run boilers, drying processes, at these sites we mentioned earlier. And basically, we're building the first one under our control next year. It's a sales tool. Folks can come, kick the tires. We negotiate a test case that says, what flow rates and temperatures do you want? We'll prove that on our first box, and if it does what you need, you buy one. So 2025, on customer sites with those first shipping container size boxes.
Charles?
I just had two questions. Can you talk about are there any safety issues related with this technology relative to the status quo? And then is the customer expected to operate the Joule Hive, or is that the service you provide? I'm trying to make sure I understand the deployment model.
Sure. So business model-wise, we look at direct sale, they operate, maintenance contract, or heat as a service where we operate. And depending on what kind, we've heard from multiple customers of different types. It's kind of two archetypes there. As far as safety goes, I would definitely say compared to other storage technologies, this is much safer in general. The thing about the bricks is they are very, very hot in an insulated box, and that's it. There's nothing chemically reacting. It's not like a battery where if something short circuits, it explodes. The energy is already there as high temperature heat. It's not any different than any other industrial furnace. So the customers that need the high heat, they're used to working with high heat systems, and so it's not so different from things they already have on site, and so they're prepared to handle it in most cases.
Thank you. Mar?
I have a quick question about the technology. Is this something you guys licensed from MIT? Is this completely new, or are there, similar bricks? People that may have used different, materials to do the similar thing.
Yeah. So I've been working at this for almost 10 years now, since 2014 at MIT. So I'm the inventor, along with my advisor, Dr. Charles Forsberg. MIT technically has the patent. We have the commercialization option.
Is it exclusive?
Yes.
Okay. Well, that's all that matters.
Go last question to Mamoon.
Yeah, I think you mentioned a 5-year payback. Could you just sort of double click into that and how that compares to the status quo?
Sure. So, the status quo in that case, the business is usually compared to is, so let's say you're an ethanol plant in the Midwest, and you're burning a lot of natural gas to make your ethanol, which is an unfortunate part of ethanol production. You put our box on site, there's an upfront CapEx to that. But we grab that cheap electricity when it's at a favorable price, and we sized accordingly, right, to have enough storage. And basically, over the course of the first 5 years, we were basically delivering cheaper energy than what they were used to burning on their status quo natural gas. And so on the 5th year, the box paid for itself. It'll keep running for another 15 years after that and keep paying back. Now, obviously, electricity rates change over time as well, but that was kind of taking a stagnant point and saying, what if this repeats? So.
Can I get one more quick one?
Yeah.
Sorry. But you do have to have the Joule Hive on site, and do these customers typically have something like that on site today?
Nothing like that on site today. Today, they just have a natural gas burner.
real estate that they need for that.
They will need real estate,
And-
that's
okay,
right.
okay.
So some folks have tons, others
Yeah.
it'll be tougher to fit, but it's a good point.
As good as in the Midwest.
That's right.
All right, thank you so much. Give them a round of applause.
Thank you.